All right, today we're peeling back the drywall. We're looking past the floorboards. We're going to uncover the hidden systems that make our homes and offices actually work. You know, the invisible architecture that's literally all around you right now.
I mean, really, just for a second, look around you. What's actually separating you from the room below, or holding that roof up over your head? Well, the answer is way more complex, and honestly, a lot more interesting than you'd probably guess.
Because you see, what we think of as just floors, walls, and stairs, they're actually these really sophisticated multifunctional systems. They're doing so much more than just, marking off space. They're the hardworking, unseen engineering that makes a building tick, keeping it safe and comfortable.
Okay, so let's start our journey from the ground up. And I mean that literally. We're starting with the floor right beneath your feet.
So, the first thing you gotta know is that architects and designers, they don't just see a floor. They see what's called a floor/ceiling assembly. And a great way to think about it is less like a plank and more like a big, deep structural sandwich. It's this one single unit that's doing a job for two different spaces at the exact same time.
And believe me, this assembly is a master multitasker. I mean, its main job is obvious, right? Structural support. But it also has to handle fire resistance, give you acoustic and visual privacy, help control the temperature, and this is a huge one. It acts like a highway for all the pipes and wires that keep a building alive.
And that brings us to this secret little world that most of us never ever see, but we all benefit from it. We're talking about the space between your ceiling and the floor of the room right above you.
Yep, this space actually has a name. It's called the plenum, and it's basically the gap where all the guts of the building run through. It's designed specifically so air can move around for your heating and cooling, and it's the main pathway for, well, everything else, from electrical wiring to fire suppression sprinklers.
And trust me, it can get incredibly crowded in there. You've got these huge HVAC ducts, steel support beams, electrical conduits, lighting fixtures. They're all fighting for space. It's really like the building's central nervous system, and the crazy part is, it's all happening just a few inches above your head.
So this gives designers a big choice to make. Do you hide all this messy stuff with a suspended ceiling? That's great for acoustics and gives you a nice clean look, but it also lowers the height of the room. Or do you go for that cool industrial loft vibe with an exposed ceiling? It can look amazing, but it costs more because now every single pipe and duct has to be perfectly finished and organized.
All right, so we've covered the horizontal plane. Now let's go vertical and talk about the walls, the things that shape our rooms and kind of our lives.
And with walls, the single most important thing to understand is the difference between a load-bearing wall and a non-bearing partition. Okay, one is a critical part of the building's skeleton. It's holding everything up. The other, it's basically just a room divider. You can knock down a partition, no big deal. But if you try that with a load-bearing wall, let's just say you're going to have a really, really bad day.
And this is exactly why it matters so much. As the author Corky Bengili puts it, you absolutely must know which type of wall you're dealing with before you even think about picking up a sledgehammer. So what's the big takeaway here? Simple. Always get a professional opinion.
Okay, so finally, let's talk about how we get between all these floors and walls. We're talking about stairs. And stairs are this incredible mix of design, how we move through a space, and some surprisingly strict science. And there's a good reason for that. Science. When you really think about it, a badly designed staircase is just an accident waiting to happen. That's why building codes are so incredibly specific about how they're built. These aren't just random rules somebody made up. They're the result of decades of safety research, all boiled down into very precise measurements. It really all comes down to getting the proportions just right. So first up is the riser. That's the vertical height of each step. In most public buildings, the absolute maximum is 7 inches. Any higher, and it starts to feel less like walking and more like climbing, which is uncomfortable and, yeah, pretty unsafe.
Okay, next is the tread. That's the flat part your foot actually lands on. This has to be a minimum of 11 inches deep. Why so specific? Well, that number makes sure that most people can get their entire foot securely on the step, which is just critical for preventing slips and falls.
And then there's this really fascinating rule for the railings. You know, the posts on the side of a staircase? It's called the 4-inch sphere rule. Basically, the gap between the vertical posts can't be big enough for a 4-inch sphere to fit true. And there's a very, very specific and important reason for that number. 4 inches is about the size of a small child's head. So yeah, this is a critical life safety feature.
So, you see how this all comes together? It's that careful relationship between the 7-inch rise and the 11-inch run that makes a staircase feel natural and safe to use. But if you get those numbers wrong, even by a little bit, a simple flight of stairs can suddenly feel treacherous, like you're climbing a mountain.
Now, stairs come in a few common shapes. Here we've got the most basic one, the straight-run stair. It's simple, it's direct, it's efficient, just a straight shot from one floor to the next.
Okay, now picture that same staircase, but instead of continuing straight, it hits a landing and makes a 90-degree turn. That's what you call a quarter-turn stair. It's a great solution for fitting stairs neatly into a corner of a room. And if you take that a step further, what if that landing led to a second flight of stairs going back in the complete opposite direction? That's a 180-degree turn, and you've got yourself a half-turn stair. This design is super efficient because it basically stacks the 2 flights on top of each other, and that saves a ton of floor space.
And last but not least, the spiral stair. They look amazing, right? Totally stunning, and they save so much space. But their use is often restricted by building codes. Why? Because those narrow, wedge-shaped treads can be really tricky to walk on, especially if you're trying to get out in an emergency.
So when you put all this together, you start to see that it's not just a random collection of parts, right? The floors create the base we live on, the walls define the spaces we move through, and the stairs, well, they elegantly connect it all. Each one is a complex system, and they all have to work together perfectly.
So I'll leave you with this question. The next time you walk into a room, are you going to see it as just a box, or are you going to see it for what it really is? An incredibly complex living machine that's silently working all around you.